Hi friends, welcome to my channel Absolute Biopharma and I am your host Pallavi and welcome to the second video of bioreactor series, that is SCADA. So without any further ado, let's start the video. So let us see what and all I am going to cover in this video. What is SCADA? The functions of SCADA, why SCADA is crucial, basic SCADA diagram, then some examples of SCADA system, which and all industries uses SCADA, software developed in the market, then some of the differences between the SCADA and PLC. So let's begin the video. So let us start with what is SCADA. So SCADA stands for Supervisory Control and Data Acquisition. So let us understand this in detail. So basically it is a category of software applications for controlling process, which is the gathering of data in real time for remote location in order to control equipment and conditions. So basically SCADA is a software application that is used to control a process, whether it is a sewage treatment plant process or a fermentation process or a factory operating process, which will gather all the real-time data, or it will capture all the real-time data and it will show to the user in order to control the situations and conditions. So functions of SCADA. First function is control industrial process locally or at remote locations. So what does it mean? It means that it controls the process that is going on in an industry or in a company. Locally means at the location, or at remote location means we can control the situation or the parameters from somewhere else. Second, monitor, gather and process real-time data. The main function of the SCADA is to monitor the real-time data, gather or collect all the data and process the real-time data. Next, directly interact with devices such as sensors, valves, pumps, motors through HMI. So SCADA is a software application that will directly interact with the devices like sensors. Various sensors are used in biopharma industries like pH sensor, biomass sensor, DO sensor, CO2 sensor. So it can directly link to those sensors and it can extract the data from those sensors. It can directly interact with various kinds of valves in the reactor. It can control opening or closing of the valves. It can control the operation of pumps, motors through HMI. HMI stands for Human Machine Interface, and it can record events in a log file. Now, why SCADA systems are crucial? First, it helps maintain the efficiency. As it gathers the real-time data, it maintains high efficiency because the data that we are capturing is online and raw. Next, it processes data for smarter decisions. Then, it communicates system issues to help mitigate downtime. Now, let us see the SCADA. So, here is a diagram in which there are sensors. The sensors will send the data to PLCs or RTUs. Then the PLCs or RTUs will feed the data to the SCADA system. Then the manual inputs which will send data to PLC. Again the PLC or RTUs, it will feed the data to SCADA system. So from both sensors and manual inputs, it will go to the SCADA. So if you understand the figure, there are sensors and manual inputs, then comes the PLCs, then come the SCADA view. So here first, the basic SCADA architecture begins with program logic controllers, PLCs, or remote terminal units, RTUs. So PLC or RTU are microcomputers that communicate with an array of objects such as factory machines, HMI, sensors and end device, then enroute the information and objects to the computer through the SCADA software. SCADA software process distributes and displays the data, helping the operator and other employees to analyze the data and make important decisions. So let us see some of the examples. So SCADA system quickly notifies an operator that a batch of a product is showing a high incidence of errors. So if there are any fluctuations or errors in the controlling system, then it will show quickly to the operator. Next comes operator pauses the operation and views the SCADA system data via HMI to determine the cause of the issue. So after that, operator reviews the data and discovers that machine 4 was malfunctioning. So the SCADA system's ability to notify the operator of an issue helps him to resolve it and prevent further loss of the product. So basically, with an example, it is clear that the function of SCADA is to notify the operator that some issue is happening and please resolve it so that our further process is not getting affected and there will be minimum loss of the product. So let us see who uses SCADA. Energy industry uses SCADA, then food and beverages industry uses it. Of course, manufacturing industry uses SCADA system. Oil and gas industry uses it. Power industry uses the SCADA system. So recycling industry uses it. Transportation, wastewater treatment plants are there. So almost in every industry you can see the SCADA system is playing a major role. So virtually anywhere you look in today's world, there is some SCADA system running behind the scenes, maintaining refrigerator systems at local supermarket, ensuring production or safety at the refinery, achieving the quality standards at wastewater plant, even tracking energy use at home. We have the application of SCADA. So let us see some of the softwares that are developed in the market by some of the companies. First is Cited SCADA. It is developed by Schneider Electric. Then second is InTouch, developed by Wonderware. Experion SCADA, that is developed by Honeywell. Then Ignition, developed by Inductive Automation. So these are some of the SCADA systems that are developed by various companies and available in the market. In some previous slides, I have used the term PLC. So let us see how it is different from SCADA and what is exactly PLC. So if we see PLC, it is a mini computer that sits out in the field within a panel. It has bunch of inputs and outputs leading from devices in the field into PLC. PLC will monitor the state of inputs like speed of the impeller. Depending on program inside, programmatically output various signals to control these field devices like stopping the impeller. And now comes the SCADA system. It sits at the top of PLC. Here data is logged and stored. The data is logged and stored in this SCADA system acquired through communication with PLC. It is used to keep log of historic state of input and output data. It is used for data analysis and auditing. So that's all for this video. I hope you got some idea about what is PLC, what is a SCADA system, how it is useful in various industries, what are its applications and how they are used in our day-to-day life. So if this video have added some value to your knowledge and if you got some information from this video, then don't forget to hit like button, do share this with your friends so that this video can reach the relevant audience, and please do subscribe to my channel. So I will see you in my next video. Till then, have a great day.